Here's another something I scored at the Harrisburg Ham Fest this past weekend. It is a Polaroid Ultrasonic Ranging System Designer's Kit. And let me tell you, this case is really overbuilt for such a small amount of material inside the kit itself, but it comes with nice, in the top of it here, a nice sleeve for all the instructions and details and schematics and specs and all that stuff. Lots of good information. And what they include in the kit is naturally some Polaroid Post power pack. These things would have been inside the Polaroid film pack that you insert into the camera. And a very convenient sleeve to hook these up. Hook up one of these batteries, slide it in there, and then hook it up to the circuit. And as for the circuit itself, and this board is the board that would be inside the camera or inside the consumer product that a developer might want to insert this into. And of course, this is the ultrasonic transducer. It transmits a pulse transmits a series of pulses for 1 millisecond, and then waits to receive the pulse through the same transducer. And then that sends signal down here to the development board and translates it into a distance measurement on the 3-digit LCD display in feet and 1/10 of a foot, and has a range of from 0.9 feet to 35 feet. Let's take a closer look at the board here. Now, the manual said that there were 2 different varieties available. There was a single frequency version and a 4 frequency version. That is the ultrasonic frequencies coming out of this. And the reason they would have more than one frequency available is because when this thing points at certain material or in certain environmental circumstances, that particular frequency might get which sends out 56 cycles of 49.41 kilohertz signal, and that'll last for about 1 millisecond. The 4 frequency version consists 8 cycles of 60 kilohertz, 8 cycles at 56, 16 cycles of 52.5, and 24 cycles of 49.41 kilohertz, for a total of 56 cycles again that last for about 1 millisecond. And this thing is, of course, full of block diagrams and graphs and all that good stuff. And here's basically how it works. There is a power on enable time right here, and then it waits a little bit, sends out 56 cycles, and then waits for the echo to return. So when it receives this echo back into the transducer, this bit will go low, and then from here to here, it measures how much time that is, and then it sends a signal to, and then it sends this to the camera or to the other consumer product. If you were actually going to use this for product development, then that would be able to determine. Now here's the board for the 4 frequency model, but if you compare that to this board, you can see how it looks pretty much the same shape on the right side and the bottom. That little notch is there. Everything's the same except for right here. It's completely cut in half, or cut down the line here, and there's some traces that are just completely cut through. You can see on both sides there. You would expect traces to continue on, but they just get cut right off. And then there's some bodge wires and resistors, and these 2 transistors are inside pins that would normally be for this IC. And that's perfectly normal. There's a section of the book for the single frequency board, and it shows a picture of that board, and then you can see how that one IC has been removed, and the 2 transistors in place, and the bodge wire and all that stuff. And then and then instructions for where to cut it if you want to reduce the size of the board so you can fit it into your consumer product. Okay, so the first thing I want to do is see if these batteries are any good. I noticed the date code, the latest date code is this chip down here, 1986, 19th week. So apparently these batteries have been sitting around for 28 years. There we go, 28-year-old battery. Look at that, 5.8 volts, should be 6, but 5.8 and steadily dropping. Probably even, I think even the 10 meg ohm resistance of the DMM is just too much for it, and it's going down real quick. Let's try the other one quick. And that's even worse, 5.36 and dropping. So yeah, there's no way these batteries are going to work for this thing anymore. I'm going to have to use some alkalines. That's another interesting spec. That's another important spec. According to the manual, it said that this thing needs a supply capable of 2.5 amps for the period of 1 millisecond that the ultrasonic transducer sends out its pulse, and then 250 milliamps average. But for 1 millisecond, the load there, for 1 millisecond, the power supply needs to give out 2.5 amps. Okay, there's a quick look at the underside of the board. Nice hand-drawn traces on there. I soldered a battery holder, 6 volt from 3 AA's, and I'm just going to turn it on and see what happens. Oh, look at that. So it's lit up. I can actually hear a little clicking noise from this thing. I can even feel on my fingers some high voltage sparks, because according to the manual this thing outputs up to 300 volts. And one thing I noticed not right now, if it's pointed down, it pegs out at 35.3 feet. So let's point it up at the ceiling. And right now it's showing 5.9 feet from here to the ceiling, 6.3 feet from the table to the ceiling. Six and a half, or rather 6.5 feet. That's not inches, that's 0.6 feet, and then I can just about make out the decimal point after the 6, so that's 6.5 feet. I should measure that to verify. And all the way down to the table, look at that. It really is it's probably closer to 6.4 feet to the table, and this thing was giving me a 6.5, but that's fine because according to the specs, it's good to plus minus 1/10 of a foot. Let's try measuring it from the floor. It's going between 9.0 and 9.1, so that's pretty good. Not bad for 28-year-old technology that's never been used before. Okay, got all the necessary holes drilled into the plastic case and into the circuit board. Standoffs are in place, and I also had to bend down the tab on this transistor here so it would fit And this capacitor just barely fits. There's only like a millimeter of clearance, but it'll work just fine. And there's the main board in the case. Power switch, LED display, and little power on LED indicator right there. And I got the ultrasonic transducer mounted on the side, some screws to keep it from popping back into the box, and the battery holder and the other circuit board, I'm just going to stuff them inside some plastic bubble wrap packaging, and then just leave that all floating around inside. I don't need to mount them rigidly down to anything. And before I put it back together, I decided to probe it a little bit. So I got the 10x probe directly across the transducer. So I'm not going to count them, but I'm pretty sure from here to here is going to be 56 pulses, and then there's some exponential. And each one of these pulses lasts a little longer than 20 microseconds, which is what you would expect since it's going at 49.91 kilohertz. Okay, now I have it on pin 6 of U1, which is the analog chip on the board, and that's going to look at the echo, the amplified echo coming back from the transducer. Well, this is very interesting. That's the initial pulse comes from RF noise. That's why it's so large on the scope. But the amplified echo back, a little more than 8 milliseconds later. Stand right in front of it, about 2 feet away. That's what we see. If I move away, then it's one last probing. This time I got channel 1 looking at the 56 cycle transmission, and channel 2 is the detected echo bit going low whenever it detects the echo. Standing right in front of it, very little delay, but if I move back, then you can see the delay increase on. I can put my hand in front, move it back and forward. Very nice. All right, well, there's all the pieces inside, all wrapped in the anti-static bubble wrap, and just the pressure of the bubble wrap, once I get this all put back together, that should keep everything fairly stationary inside. And there it is, one complete ultrasonic transducer, ultrasonic ranger. So I can point it up at the ceiling here, and it's reading about 6.0, but that's of course from here. So if I want to, I'm going to have to make an adjustment. If I'm measuring from this side, then I have to add about 0.4 or 0.5 feet